Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about basics of probability. So, what is the probability? So, probability is nothing but a chance that some event may occur, and it is the ratio of number of ways a certain event can occur to the number of possible outcomes. So probability is the chance that some event will happen, and it is the ratio of number of ways a certain event can occur to the number of possible outcomes. So normally the probability should be a numerical measure of the likelihood of the occurrence. So increasing normally it should be lies in between 0 and 1. So the probability mostly should be 0, 0.5 and between 1. So if it is 0, that means the event is unlikely to occur. And if it is 0.5, then it should be the occurrence of event is just likely as it is unlikely. And the event is almost certain to occur if it is 1. So these are the possible cases based on the probability values. So if the probability value is 0, then the event is very unlikely to occur. If it is 1, it is almost to occur. And if it is in middle of that, then the occurrence of event is just likely as it is unlikely as well. So what is an experiment and what is a sample space here? So experiment is nothing but any process that generate well-defined outcomes, and sample space for an experiment is the set of all possible outcomes. So all experimental outcome is also called a sample point. An experiment is any process that generates well-defined outcomes, and the sample space of an experiment is the set of all experimental outcomes. So the experimental outcome is also called as sample point. Then what is an event and their probabilities? So event is nothing but a collection of sample points, and the probability of any event is equal to the sum of probabilities of the sample points in the event. And if you are going to identify all the sample points of an experiment, then you have to assign probability to each, and we can able to compute the probability of an event. So event is the collection of sample points, and the probability of any event is equal to the sum of probabilities of sample points in the event. So if an event is going to occur, the probability of the event is going to be denoted as P of E, and it should be equal to the sum of all the possibilities of the sample points. Then what is an experiment and sample space? So if I'm going to consider an experiment like tossing a coin, then the expected outcomes should be either it should be head or tail. And next one is inspect a part, inspection a part that should be defective and non-defective, and conduct a sales call. So purchases, non-purchases, roll a die. The possible outcomes of the die should be 1, 2, 3, 4, 5, 6. Play a football game. It should be win or lose, or it may be tie. So this should be the experiment, and the experiment outcome should be this one. So if I'm going to toss a coin, I can get head or tail. And if I'm going to roll a dice, so I can able to get the positive outcomes should be 1 to 6. So these are the possible outcomes that we come. So play a football game that should be either winning, or it may be lose, or it may be a tie. So using simple events, so the probability of an event is nothing but is equal to the sum of probability of all the simple events contained in A. And if the simple events in experiments are likely, are equally likely, and we can able to calculate P of A. So the that should be written as NA, and that should be number of simple events divided by the total number of simple events. So using the simple event means the probability of an event should be equal to the sum of probability of all the simple events. And if the simple events in the experiment are likely equally likely, so that we can able to calculate P of A. So that should be called as the number of simple events A divided by total number of simple events. So the probability of an event is nothing but P of A, that should be in between 0 and 1. So if an event A is going to be never occur, then the probability of the event should be 0. So if an event A always occur when the experiment is performed, then should be P of A should be 1. The sum of all the probabilities for all the simple events in S should be equal to 1. And next one, die toss. So here, if I'm going to roll a die, so the sample events will be, so what is the possible outcome of 1? That should be even 1. And what should be the outcome of getting 2? That should be even 2. 3, 4, 5, 6, 5. These are the events I'm going to be considered. And sample space will be set up for all these events. And diagrammatically 100% like this. And so in sample space is nothing but all the sub events. And if I'm going to roll the events, so what is the possible outcomes? So sometimes I may get one, and sometimes I may get four, and sometimes I may get two, like this. So these are not should be treated as individual events of this sample space. And basic concept is that so event is nothing but a collection of one or more simple events. And if I'm going to die a toss, so I can able to get an odd number. A number it may be greater than 2. So for that, so what I'm going to consider is I'm going to create a set of odd numbers. So 1, 3, 5, and they should be greater than 2. So if I'm going to consider, so the event is nothing but a simple event. So if I'm going to consider so here in between the event A and B, so the events 3 and 5 should be common in between that. So 3 and 5 should be the common of two sets A and set B. Then how are going to find the probabilities here? So the probabilities can be found using the estimate from the empirical studies and common sense estimate based on like equally likely events. For example, if I'm going to toss a pair coin, so I'm going to get the probability here. And suppose that the 10% of US population has red hair, so then the person is going to be selected at random. That should be called as probability of red hair should be 0.10. For example, if I'm going to toss a pair coin twice, then what is the probability of observing at least one head? I'm going to find it out. So for first coin, I'm going to get head, and second and same thing option T. So for the second coin, I'm going to get either head or I'm going to get tail. If I'm going to get head, and that should head and tail, and then I'm write it. So the event should be treated as HH, HT, TH, and TT. So the total number of events that may occur is 4. So the probability of getting at least one hand should be 1 by 4. So that is the thing you have to be considered. And probability of event 2, that should be 1 by 4. And probability of event 1 by 4. So totally I'm going to get at least 3 by 4. That should be 3 by 4 is the probability value for getting at least one head among this tossing of 2 coins. So another example is that a ball is going to be constrained 3 ends, one red and one blue and green, and as a child selects 2 M's at random. So what is the probability of getting at least one red? So here the M should be of different colors, and what is the probability of getting blue and green? If it is blue, it is red and green. If it is green, it should be blue and red. So what is the probability? So the total number of occurrences is 6, so 1 by 6. So what I'm going to get? So probability of red green, right? So red and blue. So probability of getting red and blue, blue red, So what is the probability of getting at least one red? So I'm going to get 4 by 6. So red blue, red green. So 4 options you can able to get. So that should be 4 by 6. That should be 2 by 3. Similarly, if I'm going to what should be the sample space of this pairing of dice is just thrown off two coins. So what is the probability of obtaining 2, obtaining 3, 4, 5, 6? So the event is that so the dice is going to add 3. So for getting the 3, so what is the options we have is 1, 2, 1, 2, 1. So the probability of getting so total number of events should be 36. So out of the 36, 2 only I'm getting. So 2 by 36 is the probability value. So that value is 1 by 80. And another event is the dice that is going to get the value 6. So for this I'm going to get 1 5, 2 4, 3 3, and 4 2. I'm going to get 5 possibilities. So 5 by 36. So the red die shows 1. So what are the properties? So 1 1 1 2 1 3 1 4 1 5 1 6. So 6 by 6 that should be 1 by 6. So green die showing 1 6 by 6. So that should be 1 by 6. So like this we are going to be calculate the probability values of any single unit. Another example is that I have 40 candidates in that 26 are red, 4 are blue, 10 are yellow, and I'm going to take one of it. So what is the probability of simple A? And real world example I'm just taking. So Best Buy is having iPod given away. So they put all the iPods up in the bag. So the customer has to choose the iPod without using that color. So inside the bag there should be 4 orange color and 5 blue color, 6 green and 5 pink iPods are available. So if the Maria choose this iPod at random, so what is the probability that she going to get an orange iPod? So the total number of events that should be 20. So 4 oranges, 5 blue, and 6 green, 5 pink. So the total value is 20 events. So out of this 20 events, what is the probability of getting orange 4? So 4 by 20, 2 by 10, and 1 by 10. So 20%. So like this, we are going to estimate the probability of any kind of simple application. And next one is the deck of cards. So what is the probability of picking a heart? So totally you are going to have 52 outcomes. So out of this 52, there should be 13 hearts. So 15 by 32 is 1. And it should be 0.25, so 25%. So what is the probability of picking non-heart? So for that, the probable outcome should be 39. And possible outcomes is 52. So 3 by 4, that should be. And next one is that a computer manufacturing company is going to manufacture 2,500 computers each day. An average of 100 of these computers are written with defects. What is the probability that the computer you purchase should not be defective? So no defective should be 2,400, and then total manufactured is 2,500. So what is the probability value of obtaining this? 24 by 25. So probability examples is under I'm going to explain. So a jar contains 30 marbles and 12 yellows and 8 green marbles and 5 blue marbles. So what is the probability that can able to draw and replace the marbles 3 times that you can able to get no red marble? So the totally are going to have 35, 5 marbles are available. So in which 25 for not red. So I'm able to get it as 25 by 50. Similarly, the probability of happening 3 events 3 times in a row, that should be then happening, right? 0.45 into 3 times, that should. Next one, we are going to have multiplication rules and independent events. So multiplication rule for the independent events like B and B, and probability of A intersection B should be treated as probability of A into probability of B. For example, if the toss coin twice, so what is the probability of observing two heads? So if the coin twice, what about the probability of getting head and tail, and tail and head, and one head? So the three computers are going to be ordered, and then if the probability of getting the working computer is 7, so what is the probability that all the working? So for that, I'm going to write 0.7 into over 3, so that should be 0.3 over 3, that is 34%. And next, we are going to discuss about event relations. So the beauty of using these events rather than simple events is that we've been able to combine these events to make other events using logical operations and or not. So the union of two events like A and B is the event that should be A or B, or both can occur when an experiment is going to be performed. So for that, we're going to write it as A and B. So A and B are the two events. So the union means that the event that should be either of A or either of B or both can occur when the experiment is going to be performed. So this should be the union of event. An intersection means similarly. So if A and B are the events, so when experiment is performed, we have to write it as the intersection B. So if the two events are mutually exclusive, that means the probability of A intersection B is equal to 0. So there should not be any common point in between them, the probability of the intersection is 0. So sometimes you want to know the probability of an event that will not happen, and an event opposite to that of interest that is called a complementary event. And A is an event, and its complement is that the probability of complementary C is that event. Select a student from the classroom and record his or her hair color, gender. The the event A that should have brown hair, and B should have female, and C is male. So what is the relationship between B and C? So A complement. So student does not have A. B and C means the student is both male and female. It should be I. So a student is either male or female, and all the students that is going to be constant in this. So these are some of the examples of relationship between the events. Then how are we going to calculate the probability of these unions and complement? So there are special rules that will going to be allowed to calculate the probability of composite unions. So first one is the additive rule. So for any two events A and B, the probability of this is probability of A and B. So how can you put right? So probability of A and plus probability of B minus probability of A intersection B. So this should be the additive rule. By substituting these values of probability of A and probability of A intersection B, can you come from probability of A and B. For example, if I'm going to have, suppose we're going to have some 120 students in classroom, so they're going to be classified into various as follows. So A should be brown hair. Suppose 120 students are there in classroom, so they will be classified as follows. So A should be brown hair. So probability of brown hair is 50. So 50 divided by 120, and female is 60 divided by 120. So that should be 30 by 120. That should be 120 by 160. For example, if I have two dice are rolled, so A should be going to show the red dice once, and B should be green dice shows one. So can I able to estimate this? So probability of A and B equal to probability of A plus probability of B minus probability of intersection B. So number 36. The special case also considered. So when the two events A and B are mutually exclusive, that means the probability of intersection is equal to 5. And probability of A and B is equal to probability of A plus probability of B. So A with brown hair, so that means 20 divided by 120. female, then brown hair means 30 divided by 120. So you know that already P of A and P of B. So that should be 20 divided by 120. That is 50 divided by 1. So I can able to say that A and B are mutually exclusive. So sometimes A and B should be different to each other. Uh, so here, based on the equations, we implement this. So rolling two dice. So what is the probability of dice even is? So the dice to add 3 and dice to add 6. So the probability of A and B should be written as probability of A plus probability of B. So sum of this multiplied sum by 36. So A and B are mutually exclusive. And calculating the probabilities for the complements. So for that, what I'm going to say is that for every event, I can able to write so probability of A intersection B A equal to 5. So now so calculating the probabilities for the complement. So we know that for any event A, so I'm going to write probability of A intersection A complement equal to 0. So since either A or A complement must occur, so the probability of A union A complement equal to 1. So how can you able to write this? So probability of A union A complement is equal to probability of A plus probability of A complement. So that should be 1. So the probability of A complement is equal to 1 minus P of A. So this is the equation what you have to remember. So the entire thing should be a complement. So this is A. So the probability of A union A complement is equal to probability of A plus probability of A complement. So that should be 1. So in order to obtain this probability of A complement, that should be 1 minus 3 of A. So this is the equation you have to be remembered. For example, select a student at random from classroom. So A equal to probability of A. So that is how many number of people are available. Male 60. So 60 divided by 120. And probability of female is that. So 60 divided by what is the probability of B? That should be 1 minus probability of A. So that should be 1 minus 60 by 120. So that should be equal to 60 by 120. So this should be that. A jar contains 30 red marbles and 12 yellow marbles and 80 blue marbles and 5 blue marbles. So what is the probability we can able to draw and replace the marbles in 3 times? So that we are going to get that should be less than 1. So it is easier to calculate the probability of getting NO and then subtract from 1. So probability of AC is equal to 1 probability of AC. So in simple sense, I'm going to add 0.094. So calculating probability for intersection. So in previous example, we found that probability of A intersection be directly from the table. So sometimes it should be impractical or impossible. The rule for calculating A and B intersection, probability of A intersection B depends upon the idea and depending on the events. So the two events A and B are said to be independent if the occurrence of non-occurrence event does not change the probability of occurrence of the event. So what is dependent and what is independent events? So dependent event means A and B are the two events. Sometimes it is possible to A should be dependent on B. And independent event means that it should not be like that. So the probability of A that occurs given that event B has occurred is called a conditional probability and is going to be defined as probability of A by B is equal to probability of A intersection B by probability of B if the probability of B equal to 0. So the probability of A occurs that the event B has occurred we call as conditional probability and is going to be defined as probability of A intersection B is equal to probability of A intersection B by probability of B. So the probability of A by B equal to probability of A intersection B divided by probability of B. So if and only if the probability of B is not equal to 0. For example, if I'm going to toss a 5 coin 2 times, so the A head on second toss and B should be head on first toss. So normally I'm going to have the possibility of heads should be 4 times. So 1 by 4, 1 by 4, 1 by 4. So that means the probability of A does not change whether B does. If A and B are independent, so this should be the entire thing. So head on second toss, head on first toss. So this is another example of this conditional probability. Example 2, so a bowl contains 5 amps, 2 reds and 3 blue. So randomly selected 2 candies and define them as, so second candy is red and first candy is blue. So the probability of A by B means the probability of second candy and probability of A not B means, so probability of second red and then first red. So for this what I'm going to do that, so probability of A not B means, so probability of second red and first red, so that should be 1 and first red is 4, 1 by 4. So tossing a pair of red dice, so that should be written as probability of getting a red dice showing 1, probability of getting green die showing 1. So if I'm going to die a pair of red dice, so the probability of A by B should be written as probability of A intersection B divided by probability of B. So what is the probability of A intersection B? 1 by 36 divided by 1 by 6. So that should be the probability. Similarly, adding 3 and adding 6 are the two events. So the probability of A by B can be written as probability of A and probability of B divided by probability of B of B. So previous thing is probability of B by A, here it is probability of A by B. So probability of A does not change when B happens. That means A and B are the dependent one. Like this, we are going to have so many examples. So toss a pair of A dice is the problem. So I am going to define the two events A and B. So the probability of adding to 3 and probability adding to 6. So the probability of A by B, that means probability of A intersection B divided by probability of B. So 0 by 36, 5 by 6. So some of the key concepts of this probability distribution is that, so in experiments and a sample space, that means what is an experiment, events, mutual exclusive events and simple events. So how to know what should be a sample space and probability. So the relative frequency distribution of probability how to know, and the properties of the probabilities how to know. So normally the probability should be less than 0 and 1 and some of the all simple probabilities should be equal to 1 only. The probability of any event should be represented as P of A. So the sum of all the probabilities of all the simple events. And for counting rules, we are going to have permutations and combinations. So these P and R and these N's here. So the events are going to have events and intersections. And event should be either disjoint or mutually exclusive. That one will be written as probability of A 0. And for complementary, I'm going to write P of A is equal to 1 minus P of A complement. And what is the equation for this? The conditional probability. So probability of A by B is equal to P of A intersection B divided by probability of B. And independent and dependent events are other concepts. The two rule of probability is that, so the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If we multiply to the intersection B is equal to probability of A divided by probability of B by A. So probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. The probability of A union C equal to probability of A plus probability of B intersection B minus probability of B intersection C minus probability of B intersection B plus probability of B intersection C. And multiplicative rule of probability is that the probability of A intersection B is equal to probability of A into probability of B by A. So these are some of the basic concepts of what you have to be remember by calculating the conditional probabilities and all. So this and all plays a vital role for probabilities. So in first one, what we're going to say is a probability is an event that may be occur only once. So for this, so probability is the chance that this event may occur, and there should be a ratio of numbers that an event may occur and to the total number of possible outcomes. And increasing likelihood of the occurrence which should be lies between 0 and 1. And the experiment is the process that is going to generate the well-defined outcomes. Sample space of an experiment is the set of all the possible experimental outcomes. So the experimental outcome is called as a sample point, and event is nothing but all the collection of sample points, and the probability of any event equal to the sum of all the probabilities of the sample points in that event. So these are the examples of event and event outcomes. And simple event should be written as probability of event that should be divided by number of simple events divided by total number of simple events. And probability of the event should be defined as probability of P of A that should be less in between 0 and 1. And there should be two types of events. So if all possible events should be considered as a sample space, and the basic concept is that we have to identify the union and intersection of the events. Finding probabilities is also a question. So how much is the probability of hitting head and tail? So based on that, we want to calculate some of the examples, and then what is the probability of simple event? Update problem. And multiplication rule is there. So multiplication rule should be equation is there. Probability of A intersection B is equal to probability of A and probability of B. And event relationship A and B intersection B A complement. And for calculating the probabilities of union, so P of A, probability of A and B is equal to P of A plus P of B minus P of A intersection B. So by substituting all these values, we are going to get the total value. And we are going to be special case mutual exclusive, that means probability of A intersection B equal to by 0. So that means P of A and B is equal to P of A plus P of B. And conditional probabilities. So the equation for the conditional probability is probability of A by B is equal to probability of A intersection B divided by probability of B. So but the probability of B should not be 0. So failing it twice, and these are some of the key concepts.
Like, share and subscribe. Hit the bell icon for more updates.